electrode. We arbitrarily set that electrode to 0, and we measure all our potentials relative to that one. Here's an extensive table. Let's look at just the top half, those with reduction potential greater than the standard hydrogen electrode. So here those are expanded. We can look at the top one. Here's permanganate being reduced. Now, when permanganate is reduced, that has a high reduction potential. But if it's going to be reduced, those electrons must come from somewhere. It must withdraw those electrons from some other compound. So as it is being reduced, as this reduction occurs, the permanganate is oxidizing something else. That is, when you pull electrons off and become reduced, you had to oxidize something. The process of pulling electrons off something is an oxidation. So high reduction potential means you have a strong ability to oxidize. So the permanganate ion can oxidize any of the products here listed below. And in fact, all these products and the products in the lower half of our table as well. So permanganate can oxidize gold and bromide ions and silver, etc., all the way down. And gold ions can oxidize the water and the silver and the copper. You can also use it to bracket relative oxidation strength. For instance, Br2, bromine liquid, when it is reduced, it could oxidize silver metal, but it would not be able to oxidize gold metal, which is higher on the table. Let's look at the lower half of the table. We can also look at those reduction potentials lower than the standard hydrogen electrode. But the same rules apply. We'll have nickel, when it is reduced, able to oxidize those compounds lower. In contrast, it means calcium, metal, is a strong reducing agent. That is, the preferred direction is essentially the reverse direction, to give up electrons and form calcium ions. If you give up your electrons, something else must accept them, and that thing that accepts them becomes reduced. Its oxidation number is reduced by accepting negatively charged electrons. So our table of standard reduction potentials allows us to compare relative oxidation and reduction strengths among the compounds on the table.